Alright everybody, what we're going to be talking about is your Algebra 2 parent function one-pager. You guys can read through this, but I'm going to go over some key words that you need to understand. When you're doing a one-pager, you're making a creative project to let me know that you understand the topic. Alright, and the topic is parent functions that you're going to see in Algebra 2, and all the different types of functions that we're going to run into through the years. We're just going to do just the parent functions. Alright, if you don't know what a parent function is, we're going to talk about that. Now, you are going to use unlined white paper. You're going to title it appropriately to reflect the content, which is parent functions. You can call it parent functions of Algebra 2. You can use colored pencils, pens, markers. You're going to fill the entire page. So make sure you're being very precise and accurate with your drawings and your tables and your equations. Alright, and so you're going to be working on identifying certain characteristics. Now these are characteristics that each graph may or may not have. Not all graphs have maximum or minimum. Not all graphs have asymptotic behavior. So we'll talk about what those are in class when you run into different things. So here's an example that I have. It's called a linear function, something you should have seen in Algebra 1. So this is the parent function. This is y equals x, or f of x equals x. That's the equation. The domain, it goes from negative infinity to positive infinity. This is called interval notation. So I'm going to go ahead and start kind of drawing on this and highlighting different keys. So one of them right here is talking about the domain. So the domain runs from left to right. And this domain runs from negative infinity to positive infinity. The range goes from how far does it go down to how far does it go up. And this is considered to be the range. So I'm going to go ahead and highlight those. Alright, see here. The range is right here. That's in red. That's the range. And the domain, let me change that color real quick to blue. There's the domain right there. So that's the domain. That's the range. I'm not going to type on it or write on it. You can figure that out. Now the y-intercept and the x-intercept, you'll notice, is right here at 0, 0. So those are certain qualities that this graph only has. It runs through the x-intercept and the y-intercept. Now other parent functions also do that, but this is one of those qualities. Now you can also see that this is definitely increasing. I'm just going to highlight. It is increasing from negative infinity to positive infinity. So when you're interpreting a graph, you always interpret it from left to right. So you can see that it is definitely increasing from left to right. Now we're going to talk about what's an odd function, what's an even function. Odd functions are symmetrical with respect to the origin. So if you look at this right here where it says WRT, that means with respect to. So basically it means if I have a point that's right here, there's going to be a point perfectly across the origin that is symmetrical to it. So that's what we call an odd function graph. An even function graph is when it's symmetrical about the y-axis. So if I had like a point here, there'd be another point perfectly on opposite sides of the y-axis. Those are called even functions. So some, like a linear function, is considered to be an odd function, whereas a quadratic would be considered to be an even function. So these are criteria that you need to identify when you are making your graph. Now, there are certain graphs that you may not be accustomed to. You should all know what a linear is and what a quadratic is. But you may have forgotten what an exponential function is or a logarithmic function. You've never heard that before. This is where you use Google. So you're going to go to Google, and for example, let's just talk about the square root function. So I'm going to go over here, and I'm going to open up Google, and I'm going to type in, what the heck is a square root function? Okay, square root function. Oh, hey, look, there's pictures of square root functions. And it looks like it says the square root of x. So what you could do is go to Desmos, which is a really good graphing calculator. All right, go to Desmos, open up a tab, hit the graphing calculator, and you could type in f of x, which is in function notation. You could put f of x, or you could put y equals. But I'm going to type in the square root of x. There's a couple ways to do this. You could type in SQRT, which creates a square root. Or you could go to this nifty little keyboard right here, find the square root button, and type in an x. And there's the picture of the graph that you would draw on your one-pager. If you need to get a table from it, you hit the gear symbol, you hit the table, and voila, you have your table. So basically, the points that you would want to plot would be a 1. You wouldn't want to plot a 2, but you could definitely do a 4, Okay, you could do a 9. But I would say, for you, I would probably say 0, 0. That's the first point. 1, 1, 4, 2. And then you're just kind of drawing a graph. So this could be your table, and this could be your graph. Now, this does not go on forever. All right, so this domain basically starts at 0. So how would you write the domain in interval notation? So I'm giving you a quick little heads up. You can write this down for the domain. You would have to make what's called a hard bracket. That means equal to. So the domain starts at 0, and then it travels, continues to go on forever to infinity. So you'd have to make that cool little infinity sign. And since infinity, you can never touch it, you got to finish it with a soft bracket. So this is how you would write the domain in interval notation. So you can label it domain, and there's the domain. Now the range, it also happens to be the same thing because it starts at 0 and it goes up forever. So you would write the same thing for the domain. So if we went back real quick, you can kind of see. So in this one, the domain went from negative infinity to positive infinity, whereas on this one, the domain went from 0 to infinity. I realize this is a lot, and that's why you're going to be given multiple days to be able to complete this assignment. So what are you going to have to do? You're going to need to write down the criteria for all of these. Now we're going to talk about which functions have asymptotic behavior. I'll give you a hint. Exponential functions and logarithmic functions are these two. They both have asymptotic behavior. So when you're graphing those, you're going to have, now what is an asymptote? An asymptote is basically a boundary in the graph. So I'm going to do one quick little function right here. I'll go to Desmos, if it'll let me. There we go. So we go to Desmos. Now, if I put y equals 2 to the power of x, you see an exponential graph. Now this is if you have a base of 2 raised to the power of x. What is an asymptote? The asymptote here would be at y equals 0. You have a horizontal asymptote that runs right here. So that's called asymptotic behavior. This is an exponential function. Whereas if you had the reciprocal function or the rational function 1 divided by x, you actually have two asymptotes. You have an asymptote at x equals 0 and an asymptote at y equals 0. And if you zoom out, you can kind of see how this graph does not cross those boundaries. So we have two asymptotes, and those are things that you would need to label on the rational function, also known as a reciprocal function. So those are called asymptotes. So if you have questions about those, you could certainly ask me in class, and I will be able to explain to you more. So, in summation, I want to see all of these different types of functions. You Google them, you find the parent functions, and you draw a graph, a table, an equation, and you identify different characteristics on the graph, and you make it awesome. And just so you know, creativity will be rewarded. All right, so if you have any other questions, feel free to reach out to me, and I will do the best I can to answer them.